in the next lecture of trap distribution. In this lecture, we will mainly talk about the two known sets of a trap which are connected together but without satisfying the root, or sometime it also not specify the mode between two origin and destination metrics as well. Okay. So again, to just to give you a short brief, in the trip distribution model, we only try to find out the number of traps that occur between two origin. So one will be the origin and the another zone will be destination. So through that model, we usually predicted the number of traps originating in I or J zone, okay, or in the any of the two zones as well. In this lecture, we will talk and solve the example on the growth factor problem as well. And we will also consider the gravity model as well, so that how we can use the gravity model to evaluate or find out the trap distribution. So in this first picture, which I draw it for that specific section, so just to give you a very brief overview. So as you can imagine that origin I, uh, from zone 1, we have 4 different zones such as J1, J2, J3 or J4. Okay. So the one is basically, for example, your work location, another one is a school, while third one is kind of a park or like recreation activity or like market or something. Okay. So all those destinations are actually existed or located with different number of populations. So now, first of all, we will try to understand that how we can apply the gravity model to understand the trip distribution. As you can see here at your left side, we have the gravity model. So now we would like to identify. So in a very simple word, from origin I, the more people will go to different destination, which is denoted with J1, J2, J3, J4, which is completely dependent on few things, such as what? Such as if it provide more number of jobs, it if provide more number of choices which could be resolved within those destination, or which could also provide the multiple options such as leisure, shopping, health, education, medical facilities, etc. Okay. So again, to predict the movement of the people and good between two places, we usually use the gravity model. So again, in the original gravity model, as we will discuss in the next slide of the Newton gravitational law, is you can see here, uh, gravity model is used for the trip distribution, which actually state that number of trips between I and J are like one or two different two zones is directly proportional to the number of attraction. So means the one parameter which we can consider as a factor which could increase or decrease the number of trips, which could be so for the purpose which is inversely proportional to the function of two things. Number one is the time, and the second is the travel distance between those two zones. Okay, as you can see here, according to the Newton gravity law. So according to the gravity definition, the gravity is actually a force which pull uh, different particles or like matters or like items to its toward its earth to attract everything. Okay, so which is, for example, force is directly proportional to the different masses. We according to the Newton law, we just denote here with m1 and m2, which is again divided with the factor of the distance. Okay, and the same gravity law, if we talk about in terms of distribution, so we have we denoted with ij, okay, which we call basically the interaction factor, which is the g or the gravitational pull is denoted with alpha. Okay, and P1 and P2 are actually masses, which is the places of origin and destination, which we call it attraction or production as well. And is the denominator factor is destination where it want to go. Okay, is in the right slide, which is mentioned again, that if we have the different population in different zones, okay, so that will be if we multiply that with and divide it with the distance, but the same population. So why more people will be attracted? This is if we think that we will have a greater gravitational pole, which is kind of a direct relation with the if we have the high number of population, of course. So if the number of population is higher, so it will also need more number of jobs and also diversity in the economy, and which should provide the multiple option. The second factor is the friction. So if we have the large distance, that the gravity pull will be very less, because this is the indirect relation. So we have the one is the direct relation in terms of multiple options, while the other one is the indirect relation. Okay, so the trip distribution in your professional life, it will be graphically represented, which is already mentioned in that specific slide. For example, if there are different type of a trip mentioned in that specific figure, so we just want to give you the idea that in the real time, what type of scenario you will get for the trip distribution. So we will talk about the interzonal traps. We will also talk the intrazonal traps. We also talk about the how much poor population is actually there, how much people are actually living in each houses, which basically suggested the intra-community traps, which also states about the one zone to another zone, is you can see here in the Baltimore example. Okay, so there are 5 to 7 or 8 different locations which are mentioned in that specific slide. Okay, so which state such as the location for the shopping malls, origin, and kind of schools and offices and so on. Okay. So if we talk about in the reality, that what is basically the trip produced at zone 1 to 2 or zone 3 to 1 or 3 to 2. So we need to identify that how much trips are actually produced from one trip to another trip, which is denoted with the formula which state that Tij is equal to Pi, Aj, Fij, Kij, and so on. So each factor is actually mentioned with its classification. In the denominator, you can see here summation of n. So we can resolve or solve that specific equation for so many zones. Okay, so we don't have any restriction. The I is, yeah, for example, sometimes we call it I or J, but we can also give it number as well, such as like 3 to 1, 3 to 2, 3 to 4, and so on. Okay. Tij denote the trip produced at each zone, while Pi is basically trip produced only from the origin, okay, from zone I, while Aj is basically the all the trip which are connected from P to A, from P to from origin to the destination, while Fij is the friction factor of the interchange between zone I and zone J, okay, which we call that, which we usually uh, uh, mentioned or tabulated in the travel time as well. While Kij is we usually assume that factor model, growth factor model are is usually predict the number of trips which are produced or attracted by a different household or different traffic analysis zone is a linear function. Okay, so that specific model have different advantages as well as different disadvantages as well. But we use that growth factor model to compute or to calculate the trip distribution as well. Okay, so we will talk about the growth factor model as well as the gravity model. In the growth factor model, we usually try to identify the future trips. We try to understand the outcome of each year under the gravity model. So growth factor is basically somehow indirectly related with the gravity model. In that specific example, which state that 275 households have car, while 275 75 households are without car, and the average trip generation rate for each group is mentioned at 5.0 factor or 5.0 trips per day, while the all those people who are without car is 2.5. Okay, so what we need to identify the growth to use the growth factor model to understand the distribution, or in a simple word, we would like to understand that while using the growth factor, can we identify the number of future trips or can we identify the current trips as well? Okay, because all the data is already given in that specific slide. Okay, is you can see here for the solution, it's quite simple. So we will multiply the to identify or to compute the current trip rate. We will multiply 275 with 5.0 and plus 275 with 2.5. So we can identify the trips in a single day. But to identify the growth factor, what we actually needed, we needed the total number of trips divided by all those people who have their own car. So total number of the household, so like 275 plus 275, which is almost equal to 550. So we will divide the same factor with all those people who don't have a car. Okay, so we have the growth factor of 2.0. So the current rate trip we already kind of measured. So we will simply multiply that with 2.0. So this solution is in the next page, as you can see here. So simply we just multiply 275 with 2.5, and then and then again in the next factor we multiply it with 5.0. So to identify the growth factor, we have the total number of trips divided by all those people who have their own car. So we got the factor. So the same factor is 2.0 is multiplied with the current trip rate, which is TI. Okay, so we got the number of the future trips as well. So this was the example for the growth factor model. Now we will talk about the gravity model. Okay, so we consider three different zones from zone 1 to 3, and we would like to analyze and the whole data to determine the trip distribution while considering the gravity model. So Kij, the socio-economic factor between zone 1, 2, 3 is assumed as 1. Okay, so at one side we have the trip production and attraction data, while at the another side we have the time as well. Okay, time factor, and we have the travel time zones between each in terms of from zone 1 to 1, zone 1 to 2, zone 1 to 3, and so on. Okay, to understand or to solve the gravity model to identify the trip distribution, first of all, you need to understand that we need that matrix solution. Okay, which is, so for example, if you have two zone, so the matrix will be 2 multiply 2, means 2 columns and 2 rows. If we have the 3 zones, so we will have the column of 3 multiply 3, and if we have the 4 zones, so we will have the 4 multiply 4, or if we have as many zones, so we can do that as well. At one side, at the right hand side, in the column side, to aid all the rows, we will identify the production. Okay, and to sum all the whole column, we will get the attraction. But I will explain in the real time example. As you can see here, what we did. So for the very first step, we already in that specific question, we already got the zonal time. So we will convert the same zonal time into the friction factor. OK, so by using the travel time, for example, the friction factor was, for example, 1, 2, 3, 4, 5, 6, 7, 8. So different friction factor was already mentioned. So what we will do, we will just convert it. For example, for zone 1 to 1, so the travel time there was 5. So we have the friction factor of 39. So we just put that friction factor over there. So similarly, for from zone 2 to zone 1, so we have the travel time of 2. So 2 friction factor is 52. So as you can see here in the second column, we mentioned that 52. Similarly, the whole the table is generated. So this is the step number 2. Is it was already explained that Tij is equal to Pi Aj dot Fij dot Kij. Okay, first of all, what we will do? Okay, what we will do? We will use each factor with much detail. Okay, for example, Pi. First of all, you need to identify that what sort of available data do we have. Okay, so Pi means P1, from where the trip is actually originated. As you can see here in the trip production, we have the 140. And similarly, where the trip is actually going. So you need to understand one thing, that in the trip distribution, it should be between two zones. Okay, so one we will consider it as a production, while another one we will consider it as an attraction. So the trip was produced from 140 and it's going to the attraction factor, which is 300. Similarly, to identify the F11 or from 1 to 1, so I is also 1 while J is also 1. That's why we call it F11, so which is 39. Okay. So we can identify very easily T11. So in the denominator, you can see here that we have the summation of starting from trip attraction, which is A1 dot F1 into K11. And then we will to reach to the level of summation. So we will basically add the attraction for each zone. So like A11, A12, and then A13. And the same factor will be multiplied as well. The F11 along with KI1, which is the socio-economic factor. So as you can see here, with through a very simple solution, we can determine the T11. Okay, again, T11 is basically the trap produced at zone 1 and attracted to zone 1. Okay, similarly, the same step we can do for the trap generated from T1 to 2. Okay, so Tij, and so I is 1 while J is 2. Okay, in that condition, or P1 is 140 while the A2 is basically, or AJ is basically 270. Okay, so it's moving from zone 1 to zone 2. Okay, so you need to understand that step. It's very important. Okay, so we will consider the always the trip production at P1 while we will only change the A2 factor. Okay, the rest of the figure is almost the same. So A11, F11, K11, and so on. Okay, so we can identify easily T12 and T13. Okay, so moving to the T21, we will use the same formula. Okay, but for that specific, you need to understand that only the P2 value or PI value will be changed, which is the now we are talking at the zone 2, which is 330. Okay, while for the A2 we will start again from the 300. Okay, so again, so like T2, so like P2 is basically 330, but A2 is again 300, okay? Because it's 321. As you can see here, A1 we will call it to the 300, A2 is 270, while A3 is 180. So through that simple equation, we can compute the T21 as well. The same model could be used for the T2 T22 and T23 as well. So now we are moving from the zone 3 to zone 1. Okay, so now we would like to identify all the trips which are produced from zone 3 to zone 1. So in that specific scenario, zone 3 is our production, while zone 1 is our attraction factor. As you can see here, while using the same formula, so we have the P3 value is because all the trips are generating from zone 3, which is 280, while A2 or A3 is again 300 because we are again talking about the trip production. Okay, so trip production will always be 300. So while computing that simple equation, we can get the T31 as well. Similarly, we can do that for T32 and then T33 as well. In the last step or in the last stage, we will add all those. For example, we want to see that all those steps which we just solve it to identify the T12 or 12 or 13 to fill all those rows and column. So we will put the value in that specific matrix, and we will identify the summation of row along with summation of column. So we will basically compare the same value with the trip production and the trip attraction, okay, which we will identify in the next example. That next example is we would like to see, for example, if we have the zone 1, 2, 3, and we have different factors such as starting from 104, 105, 105, 6, and 104, 8. Okay, so the one is we have the computed value, okay, which we basically kind of measured while resolving the Tij, okay, that gravity model, and the sum of original, for example, if we add 104 with 156 and with 148, so we got the 360. But if we compute the difference, okay, between the computed value and the original sum, which is almost 48. So we will do the same practice for each row in each column. Okay, as you can see here in the bottom one, in the row, so we have the original value of 330, while computed value is 320. So we have the difference factor of 10. So the difference factor need to be there is a marginal of not more than 5%. Okay, so again, it's quite higher. So now what we will do? We need basically to use the iteration model to reduce the difference to achieve the convert solution while using the gravity model. For that, what we will do? Okay, so we need the original row sum column divided by computed value. So we will get the factor from that, and then we will multiply the same factor with the same row and with the same column for the purpose to reduce the difference. That's why it's called the converged solution, or while using the iteration model to achieve the converged solution to reduce the difference. Okay, look, first of all, we got the zone 1 to zone 3, all the parameters, and then we resolve it. And then again, we compare it with the original row sum and with the computed row sum. So this is again, if you guys kind of remember the mathematics we did in our previous classes. So like if we would like to balance the left hand side with the right hand side. So this is the same kind of concept, but here we call that difference, and that difference need to be reduced through the iteration model, as you can see here. So that specific factor is again receive, and that factor we will multiply it with the row and column to reduce that factor. So if it's somehow in the marginal difference of 5 to 7%, then our model is calibrated. This is example number 3, to use the iteration model to find out the kind of adjusted attraction. So we can use that model as well. So the given attraction divided by the computed attraction multiplied by the given attraction to adjust all those traps. OK, so these are the 3 different examples while using the gravity model. If you guys have any question, you can get back in the comment section. Thank you very much. Have a nice day.